Okay, so this is chapter 4 and we will discuss nuclear chemistry ngayon. So dito natin ma-address yung mga issue about nuclear science, no? Bakit ang daming natatakot sa kanya? Bakit siya yung pinopromote ko, no? As an alternative, no? And ano ba yung mga risk and harm and what else could we do about it, no? Okay? So, madidiscuss natin yung mga bagay na yon sa chapter na to. Okay? But again, basic lang yung idea sa nuclear science, no? Sa nuclear chemistry, ano lang yan. Parang nag-stoichiometry ka lang din. Okay? Madali lang siya. Okay? So basically, ito yung mga i-discuss natin. Medyo marami pero mabilis lang yan. Okay? So una, we will discuss what is the nature of nuclear reactions. Ano kaya yung difference niya with the usual chemical reaction? Magkaiba yun eh. Iba yung nuclear sa chemical reaction. Okay? So discuss natin yon. And how do nuclear equations look like, no? Medyo iba siya compared to chemical equations, no? Pero madali lang siya maunawaan, no? So mamaya discuss natin yan. Then we will also discuss the types of radioactive decay. Marami yan. So actually, 6 yung uri ng radioactive decay. We will discuss each of them. Radioactive decay series. Ayan. Nuclear bombardment, radiation and matter. Ito yung biological effects. Dito na discuss ano yung mga effect niya sa katawan, what are the pros, what are the cons, no? The rate of radioactive decay, which is used in carbon dating, para ma-predict kung gano'n na katagal yung mga artifacts sa mundo. Kung millions of years ago pa siya, thousands of years ago, dito yan, sa nuclear yan. Okay, and then applications of isotopes, energy, and nuclear fission. Okay, so ano lang to? Madali lang to as long as you know yung pagbilang ng protons, neutrons, electrons. Okay, so ganun, dun lang kasi umiikot tong topic na to. Protons, neutrons, electrons. Okay, so anyway, so discuss na tayo with the nature of nuclear reactions. Okay. So, maganda i-compare to sa chemical reaction kasi dalawa lang naman yung uri ng reactions sa mundo, no? Either it is nuclear or chemical, okay? So, magkaiba yung nuclear sa chemical. Okay, bakit? So, itong table, intindihin natin. Okay? So, in chemical reactions, atoms are rearranged by breaking or forming the chemical bonds, no? So, ito, medyo may idea kayo dito, di ba? Noong thermochemistry, may topic tayo doon na we have a molecule, kunwari, glucose, tas, di ba, pinuputol-putol natin yung bonds, no? Pag nag-combust yun. So, basically, ganun yung chemical reaction. You just cut the bonds, no? Okay? So, ibig sabihin, yung mga electrons lang ang involved sa chemical reaction. Okay? Kasi ano ba yung mga nasa bond? The electron, okay? So, ibig sabihin, electrons are the only thing involved in chemical reactions. So, paano sa nuclear reaction? Sa nuclear reaction, medyo kakaiba. Hindi lang electrons yung involved. It also involves protons, neutrons, electrons, and other elementary particles, no? Such as positron and gamma rays, ano pa ba? Mga alpha particle, ayun. So, involved sila. Okay? So, yun yung pagkakaiba. So, kapag pag nuclear reaction, kasama yung nasa loob ng atom. Okay? Kasama yung proton, neutron, electron, positron, gamma, beta, ayun. So, alpha particles, lahat ng mga yon kasama. Okay? So, ibig sabihin, medyo weird itong nuclear reactions, no? Okay? Medyo weird siya. Okay? So, yan. So, paano siya naging weird? Basahin natin itong number 1. Elements are converted from one to another. Okay? So, kasi kapag chemical reaction, yung element natin hindi nagbabago, di ba? Sabi yun, law of conservation of mass, no? Pero, kapag nuclear reaction, yung element nagbabago. Okay? So, kunwari, from nitrogen, magiging carbon siya. Okay? So, siguro naisip nyo, hala, baka violation yun ng law of conservation of mass. Actually, hindi, no? Okay. Actually, hindi siya violation of law of conservation of mass kahit na nagbabago yung element na. Kasi, yung protons, neutrons, electrons, yun yung binabalance natin this time. Okay? So, hindi na siya yung atom lang. Yung mga protons, neutrons, electrons, yung binabalance natin sa nuclear reaction. Okay? So ito yung ito parang ito yung sagot sa search nila for the philosopher's stone, no? Okay. Basta yung something na ganun sa alchemy. 'Di ba ang goal ng mga alchemists dati is to convert everything into gold, no? Okay. So in order to convert something to gold, hindi mangyayari yon, never. Okay? Never mangyayari yon. Kunwari, yung kahoy, gagawin mong gold, di pwede yon. Pero, kapag with nuclear reactions, you can convert one element to another. Okay? So, parang ito yung pinaka-alchemy. Okay? So, ito yung modern version ng alchemy, yung nuclear reactions. Kasi yung elements pwede mo na i-convert. Na. Akala nila dati bawal pero pwede pala. Okay? So yun yung major difference niya with chemical reactions. Okay? So yan, take note, since involved ang protons, neutrons, electrons, the atoms will change, no? Will change or may not, pero mostly they change. So ito rin yung reason why maraming elements sa ating universe, okay? So imagine nyo, in the beginning, no, nung Big Bang, no, hindi tayo biblical. So in the beginning, puro hydrogen lang yun nasa universe eh. Pero how come kaya na nagka-carbon? How come na nagka-iron? How come na nagkaroon tayo ng gold, no? How come na nagkaroon ng bromine? Okay? Paano kaya nagkaroon ng mga ganun, no? So, sagot doon, nuclear reaction. Kasi, basically, ang nangyari in the beginning, no, sa start ng universe, we start with one hydrogen only. Then, if you combine the protons, dadami na yung elements mo. Kakaroon ka ng helium, lithium, beryllium, boron, carbon, until the last element, the organeson. Okay? So, ganun ka-amazing yung nuclear reactions. Okay? So, yan. So, ayan. So, ito yung pinaka-key sa creation natin mismo. Okay? So, ito yung mga nangyayari noong creation of the universe. No? Okay? So, without nuclear reactions, we will not exist. Okay? Kasi walang carbon dati. Okay? So, ayan. So, take note of those two differences. Ano pa? Chemical reactions are accompanied by absorption or release of relatively small amount of energy. No? Kunwari, bomba, mahina pa yun. Okay? Mahina pa energy nun compared sa nuclear. Okay? So, how? No? Imagine nyo, yung mga bomba, chemical reaction yun. Combustion reaction yun. Pero kapag sinabing nuclear reaction, yun yung nangyayari sa star. Okay? Kung sino mas malakas, yung star o yung bomba? Edi yung star. Okay? For example, yung sun natin. Ayan. Okay? So, yung sun natin, doon nangyayari yung mga nuclear reactions, no? So, ibig sabihin, mas malakas yung energy ng nuclear kaysa sa chemical, okay? So, that's why, kapag tayo ay usapang energy production, mas efficient yung nuclear power plants kaysa sa coal power plants or any chemical power plants, no? Okay? Bakit, no? Kasi nga, mas maraming energy involved sa nuclear reaction. Bakit? Didiscuss natin yun mamaya. Okay? Discuss natin mamaya kung bakit mas maraming energy sa nuclear kaysa sa chemical. Okay? Pero yun na lang, no? Imagine nyo na lang, if etong nuclear, mas marami siyang energy na mapoproduce, edi mas maganda siyang alternative form for energy source, di ba? Kasi kapag sa Pilipinas ngayon, majority ay coal power plant, no? Around 40% ata. Coal power plant, sinusunog yon. So, chemical reaction lang yon. Pero, imagine nyo, if we run our nuclear power plant, which is okay naman daw, sabi ng PNRI, okay, pag pinagana natin yung nuclear power plant natin, mas malakas yung energy na mapoproduce natin. Okay? So, yan. So, mas malakas siya, mas energetic siya compared to chemical. Okay? Ang reason bakit is di-discuss natin mamaya o kaya sa mga susunod na meeting. Okay? So, discuss natin yan. Another thing, rates of reaction are influenced by temperature, pressure, concentration, and catalyst, no? So, sa chemical reaction, it can stop, no? Kapag wala ng reactants, no? 'Di ba? Kaya nga meron tayong limiting and excess reagent na topic dati sa Gen Chem, 'di ba? Kasi alam natin, kapag naubos na yung reactant, no reaction na. Okay? Pero sa nuclear reaction, it is self-sustaining. It is not affected by any of those factors. No? Self-sustaining yan. That's why yung star natin, continuous na nagdo-nuclear reaction yan. Okay? Continuous yung reaction sa sun. Okay? Kasi nga, self-sustaining siya. It doesn't need any other reactants, no? It can go by itself, no? Ibig sabihin, ano siya, kaya niya mag-isa. Okay? So, compared sa chemical reactions na umaasa siya sa iba pang molecules. No? Okay? So, self-sustaining, that's why when you start a nuclear reaction, it will continue until thousands of years later. Okay? For example, sa Chernobyl, this is an accident naman. So, sa Chernobyl, yan, nagkaroon ng nuclear accident and that place will be not good for habitation for thousands of years pa, no? So, siguro patay na tayo, doon na siya pwedeng maging okay, no? Doon lang bababa yung mga radiation levels doon, no? So, pero yun yung yun yung dito sa number 4, no? That nuclear reactions are self-sustaining, no? It can last a very long time, okay? So, yan. By the way, discuss din natin yung nuclear safety in the siguro next week. Okay. So, yan lang ha. Those are the major differences of chemical reaction and nuclear reaction. However, medyo similar sila because they follow the law of conservation of mass. Okay. So, yan. In summary, take note natin. Kapag chemical reaction, electrons ang involved. Pag nuclear reaction, it involves proton, neutron, electron, and other elementary particles such as alpha, beta, gamma rays. No? Positron, okay, so mga ganun. Ano pa? Chemical reactions produces relatively small amount of energy compared to nuclear. Okay? So, ang good comparison dyan ay bomba, pati star. Okay, yung sun. Sino mas malakas dyan? Edi yung sun, no? The sun is the sun is burning itself, no, for billions of years already. Okay, so ibig sabihin mas malakas yung nuclear kaysa sa chemical. Okay? So also, chemical reactions are dependent on these factors: temperature, pressure, concentration, catalyst. Pag nuclear, it is not dependent on those on those factors. No? Hindi siya dependent sa ibang molecule, dependent siya sa sarili niya lang. No? So kung kaya niya mag-nuclear reaction, gagawin niya. Okay? So ganun. Self-sustaining din siya. So kaya matagal-tagal siya bago huminto. Okay? So ayan. So, those are the major differences, no? Pero kailan nga ba na-discover yung nuclear science? Actually, very recently lang, no? So, this is a form of chemistry na very recent lang, no? And ito ay nakatulong sa development ng quantum mechanics kahit paano. Kasi dito nila nalaman na yung atom ay maraming particles sa loob nun. Okay? So, big sabihin, may yung timeline ng atomic models natin nag-overlap sa nuclear chem. Okay? So, kasi nung na-discover nila yung nuclear chemistry, doon nila nalaman na yung atoms natin, marami pa pala siya sa loob. No? Marami pa pala siyang laman sa loob. Okay? So, kailan nga ba na-discover yung nuclear reactions? No? It was in 1896 when it was discovered, more than a century ago, by Henry Becquerel, Antoine Henry Becquerel. So, ano nangyari dito? So, meron siyang metal ore. I think uranium yan, okay. So, meron siyang metal ore na nilagay niya sa isang photographic plate, no? Parang papel. Alam mo yun sa X-ray, parang pinatong niya lang yun doon, tapos nilagay niya sa cabinet. Tapos, after some time, no, kinuha niya uli yung metal na yon and then yung frame. Pagkatingin niya dun sa plate, no, yung parang papel ng X-ray, nakita niya, may something na nangyayari dun sa film, sa photograph film ng X-ray. Parang nag-develop siya ng ganitong development of nuclear science. Later on naman nila na yung uranium, marami pala siyang nilalabas na particles that causes this image to be developed, which we use now sa X-rays natin. Okay? So, ganun yung mga nangyayari. Okay, so yan yung na-discover ni Becquerel, Pinatong niya lang yung uranium sa isang film, okay? Tapos, later on, nakita niya yung film, dumilim. Okay, ibig sabihin, there's something emitted by the atom itself, okay? And later on, yun ay naging X-rays, And then, marami silang na-discover na iba pang uri ng rays, Okay? So, ito naman, another development of the of nuclear science is this one. Ito yung ginawa ni Ernest Rutherford, hindi ko nasulat yung pangalan, dito na lang. Ernest Rutherford, Okay, so you are familiar with the gold foil experiment by Rutherford, okay? Kasi na-discuss to ng Gen Chem. So, ginawa naman ni Ernest Rutherford, he investigated also on the metal, yung uranium, okay? So, nilagay niya yun sa isang container and then pinatamaan niya yung isang gold foil dito. And napansin niya na may iba't ibang rays na lumabas. Okay? So, parang gold foil experiment na. So, doon, depending on the behavior of the particle emitted by the mineral, okay, doon niya na-discover na mayroong mga alpha particles which are positively charged. We have the beta rays which are negatively charged. And then we have the gamma rays that are uncharged. So, yan. So, ito yung gold foil experiment. Extension siya. So, dito na-discover na yung ating mga radiation ay marami pa pala. Hindi lang siya X-ray tulad ng sinabi ni Becquerel dati. Marami siya. Mayroong alpha ray, beta ray, gamma ray. Okay? So again, take note, alpha ray is positive in charge, beta ray is negative in charge, gamma ray doesn't have any charge. Okay? So later on, discuss pa natin ito. So yun yung development. And then later on, na-discover nila na itong nuclear reaction pwede gamitin sa bomba. Kaya nung World War II, ginamit ng American yon to bomb Hiroshima and Nagasaki. And then natapos yung World War II. Then yan, doon na na-develop yung mga nuclear power plants and then inayawan ng tao yung nuclear power plants dahil sa Chernobyl, then gumamit sila ng coal, nagka-global warming, and then yan, malapit na tayo mawala sa mundo. Okay, so yun yung timeline natin. Okay, so basically, ang discovery ng nuclear reactions ay accidental lang, So, nilagay niya lang sa cabinet, tapos may na-discover siya, tinawag niya X-ray. And then later on, that was further investigated by Rutherford and na-discover niya, we have the alpha, beta, and gamma rays. Okay, so that also led to the development of modern atomic theories. Mas naka-discover sila na yung atom, di lang siya bilog, marami pa siyang laman sa loob. Okay, so yun yung start ng modern science, with the help of nuclear science. So yun lang yung timeline, medyo maigsi lang. We will not discuss it further. Pero yan lang, ang take note niya lang mga tao dito, si Becquerel and si Rutherford. Okay? And then doon papasok si Marie Curie, Siya yung nag-further investigate nito, Pero di na natin siya i-discuss. Okay. So anyway, so let's talk about nuclear equation naman, So familiar tayo with chemical equations, Kasi ang chemical equation, madali lang 'yon, 'di ba? For example, we have C6H12O6 plus 6 oxygen producing 6 carbon dioxide and 6 water. Chemical equation yan. Mapapansin mo, kapag chemical equation, kung ano yung atom sa left, yun yung atom sa right. Kasi yun yung sabi natin, yun yung mga sinabi namin, ng mga teacher nyo. Pero kapag nuclear equations, hindi ganun. Okay? Kasi tignan nyo, for example, this is a nuclear equation here. You have uranium on the left side. Then on the right side, you have thorium and helium. Ibig sabihin ba niyan hindi yan balance? Actually, balance yan, no? Pero magtataka kayo, no? Bakit kaya magkakaiba yung bakit kaya magkakaiba yung elements, no? 'Di ba sabi natin kapag chemical equation, yung element dapat the same. Okay? So, different yung nuclear equation talaga kasi nga sabi natin yung isang element pwede siya magbagong anyo, okay? So, acceptable 'yun. Okay? Dati hindi nila tinatanggap 'yun pero tinanggap na lang nila kasi ganoon talaga yung nuclear equations, no? Na yung isang element magbabagong anyo talaga siya. Okay? So, 'yun. So, hindi kayo magbabalance in terms of the atoms, bale. Magbabalance kayo in terms of something else, no? Okay? So, again, this equation is balanced although it doesn't seem na balance siya, no? Okay, paano siya naging balance? Kasi ganito, ang nuclear equations natin, they are balanced in terms of the protons, neutrons, and electrons. Okay? Basically, protons and neutrons yung binabalance natin. Okay? So once they are balanced, then the equation is balanced even though iba-iba yung elements. Okay? So it still follow the law of conservation of mass kasi yan nga, same protons, neutrons in the end. No? Kaya it still follows the law of conservation of mass. Okay? So yan, so nuclear equations are quite different, okay? So it doesn't follow our traditional chemical equations, hindi same yung elements. Mag-iiba yung elements talaga because that's the nature of nuclear equations. Okay? So paano mo siya ibabalance? Hindi siya in terms of elements, rather in terms of protons and neutrons. Okay? So ganun yung gagawin natin, protons, neutrons. How do we represent the elements ba in nuclear equation? Kasi kapag chemical equation, molecular formula, no? Kunwari C6H12O6, O2, 'di ba? 'Di ba ganun kapag chemical equation. Kapag nuclear equations, we represent it by the nuclear symbol. Okay? So this is the nuclear symbol. Okay? So, yan. Nakaganyan yung ating mga elements dito. Naka-nuclear symbol. I know you are familiar with this. If not, baka nakalimutan. Na-discuss to ng Gen Chem. Okay. So, ito yung mga nuclear symbol natin. Ganito nakasulat yung mga reactants and products sa nuclear chem. Okay. So, discuss natin only ano yung mga nasa nuclear symbol. Okay. So, yung letter na malaki, ito yung element symbol natin. Okay, so, yan yung element symbol natin. So, yan yung H, He, Al, Br. Oh, yan yun. Yung mga element symbol. Yan yung mga nasa periodic table. Okay? Yung number sa baba, bottom left, ayan. Ito yung atomic number. Okay. So, that is the atomic number. Okay? For example, atomic number 3. Anong element yan? Tingin ka sa periodic table. Yung ikatlong element, yun. Okay? So, atomic number 3. Lithium yun. Okay? So, ang atomic symbol niya, Li. Okay? Tapos yung number niya sa bottom left ay 3. Okay? So, yun yung atomic number. Kung ano yung number niya sa periodic table, yun yung ilalagay mo. Okay? Kunwari, zirconium, 40. Okay, so ganun. So for each element, mayroong distinct na symbol. Okay? Teka lang. Wait lang, may naririnig lang ako na aso sa baba. Wait lang na. Yung aso gumagano sa pinta. Ayun. Anyway, let's proceed again. So, atomic number, ito yung number of protons din pala. Okay, so do not forget that. It is equivalent to number of protons. So, I believe na-discuss na to dati, no? Pero share ko pa rin. Okay, so yun yung atomic number of protons. Yung top left naman, this is the atomic mass. So that is the atomic mass. Okay? And sabi natin sa Gen Chem, atomic mass is the sum of the proton plus neutron. Okay? Bakit kaya ganun? Bakit ang atomic mass ay proton plus neutron? Kasi, sabi nila, sa isang atom, di ba tatlo laman nun? Proton, neutron, electron. Yung protons and neutrons, sila yung malaki yung mass. Okay? So, sila yung may malaking mass compared to the electrons. Ang electrons kasi virtually, it doesn't have any charge. It doesn't have significant mass, no? Compared to the proton and neutron. Kaya, hindi siya sinasama sa atomic mass. Okay? So, basically, itong number na to ay proton plus neutron. Okay? So, atomic mass, proton plus neutron. And then, itong nasa top right, this is the charge. Okay? So, medyo familiar tayo dito sa charge kasi nagamit natin to this semester, no? So, that is proton minus electron. Okay? So, that is our nuclear symbol and how we interpret the numbers on the bottom, top, left, and right. Okay? So, yan. For example, we have uranium 238. Okay? So, ano meaning na to? Alamin natin yung protons, neutrons, electrons. Hindi, wag na natin isama yung electron. Okay. So, ang focus natin ay proton, neutron lang madalas. Okay. For example, uranium 238. Ano yung kanyang proton? Ano yung kanyang neutron? Ganito lang. Yung number sa bottom left, yun yung protons. Okay? Kasi sabi ko nga sa inyo, atomic number is the number of protons. Okay? So, ibig sabihin, kung 92 tong nasa baba niya, edi 92 yung protons niya. Okay? 92 yan. Paano yung neutrons? Ganito lang. Tingin ka sa number dito sa taas, itong 238. Ang sabi natin, yung atomic mass ay proton plus neutron. Ibig sabihin, pag pinag-add mo yung dalawang to, pag pinag-add mo yan, dapat 238 yan. So, ano yung i-add mo sa 92 para maging 238? I-calculate mo na yan. No? So, 238 minus 92, 146. Okay? So, yan. So, yan yung protons and neutrons dito sa left. Okay? So, on the left side of the reaction, we have 92 protons as indicated by the atomic number. And we have 146 neutrons. Paano natin nalaman yung neutrons dito sa atomic mass? Okay? Kasi we know atomic mass is proton plus neutron. Alam na natin yung proton, kaya hanapin mo na lang yung neutron. Okay? Subtract mo na lang. 238 minus 92 neutrons yan. Okay? So ito yung nasa left side ng reaction natin. How about on the right side? Okay? So on the right side, we have thorium. Okay. Dalawa yung nasa right side, so dalawang column gagawin ko. So on the right side, we have thorium and helium. Okay, so again, yung numbers sa baba, ito yung proton. So 94 thorium, 24 helium. Okay. And then neutron, paano gagawin? This minus that, no? Taas minus baba. Okay. So that's mass minus proton equals neutron. Okay. Saan ang galing yun, sir? Dito lang yun ang galing. Atomic mass, proton plus neutron. Substitute mo lang yung neutron. Okay. So that will be atomic mass minus proton. Okay. So that will be 234 minus 90. Kakalki ko na yan. 234 minus 90. 144. And 4 minus 2 is 2. Okay. So, ito yung ating info. So, on the left side of the reaction, we have 92 protons, 146 neutrons. On the right side of the reaction, mapapansin mo, na same lang din yung amount ng protons and neutrons. 90 plus 2 is 92. 144 plus 2 is 146 na. So, mapapansin mo, na yung protons and neutrons on the left side and on the right side of the reaction ay same lang. Okay? Same lang yung protons and neutrons on the left side and on the right side of the equation. That means balanced yan. Okay? So, ganito yung idea sa pagbalance ng nuclear equations. Okay? So, aalamin mo sino yung mga protons, ano yung mga neutrons, then titignan mo on the left side and on the right side, balance sila. 92 sa left, sa right, 90 plus 2, 92. 146 sa left, sa right side, 144 plus 2, 146. Okay? So, yun yung sinasabi nating balanced nuclear equation. Yung proton and neutron ay equal on the left and on the right side. Okay? So, it means it follows the law of conservation of mass. Okay? So, it follows the law of conservation of mass although the elements are different. Okay? So, ibig sabihin, may idea na tayo ngayon how to interpret nuclear equations, ano meaning ng numbers sa taas, sa baba, and how to balance them. Okay? So, ano pa yung mga particles na pwede gamitin sa nuclear equation? Ito. Paki-screenshot kasi kailangan natin to later. We have 11P or 11H, that is a proton or hydrogen. 10N, that's neutron. Okay? So, wala siyang proton, pero may mass siya. Isa. So, ibig sabihin nun, yung mass na yon ay yung neutron. Okay? So, 0 proton, 1 neutron. Ito yung symbol niya, neutron. Okay? Pag electron naman, ganito yung symbol, 0, negative 1e or 0, negative 1 beta. Okay? Pag sinabing beta particle, electron lang din yan. Okay? And then we have a positron. We have positive 1, 0, positive 1e or 0, positive 1b. Positron yan. And we have the alpha particle, 42He or 42 alpha. Okay? So ito yung iba pang elementary particles that we will need, no, in order to balance nuclear equations. Okay? So ganun lang. Ito yung mga dinadagdag pambalance, no. Okay. Kasi 'di ba sa chemical equation, ang ginagamit mo pambalance ay coefficient. Sa nuclear equation, pwedeng coefficient, pwedeng ito. Ay, pwede ito. Pwede ito gamitin. Okay? So, take note of the numbers sa taas and sa baba. Ha? So, they are vital when counting protons and neutrons. Okay? So, yan. Okay. So, maybe we can try to balance. Ito. Take note na lang, in balancing nuclear equations, we observe that the protons and neutrons are the same. No? Must be the same. And the charges must also be the same. Okay? So, yeah. Okay, let's try. No? Let's balance the following. Try lang. We have polonium-212 and lead-208. No? What is the missing particle? What is the question mark? How will we balance this? Madali lang. Okay? Madali lang yan. Paano? Diba sabi ko nga sa inyo, protons and neutrons must be the same. Okay? Pwede rin naman ganito yung shortcut. Yung number sa taas, sa left, it should be the same as sa number sa taas ng right. Okay? Yung number sa sa bottom left, dapat same lang din sa number sa bottom left sa kabila. Okay? So, paano yan? Ganito lang. Di ba kanina ginawa ko proton, neutron yung basis, no? Pero para mas madali buhay, ganito gagawin natin. Shortcut to. Okay? Yung number sa taas, dapat same yon dito sa number sa taas sa kabila, no? Okay? So, kailangan equal yun. So, kunwari, 238 to. So, ito, ano to? 234 plus 4. So, 238 lang din. Okay? So, yun. That's one way to balance it quickly. And best na magbilang ka ng proton, neutron. Ganito na lang gawin mo. Okay? So, bilangin mo kung ano yung numbers sa top left, ng left side of the reaction and the right side of the reaction. Okay? So, they must be equal. Okay? So, pag nag-equal yan, equal na sila ng neutrons. No? O, ganun din dito sa baba. No? Kung 92 yan, sa bottom left, kailangan yung bottom left din ng nasa right side ay same lang din. So, 90 plus 2 is 92. Okay? So, yan. Okay, papansin mo, balance sila. So, ganun gagawin natin dito. Okay? So, just add yung top numbers and yung bottom numbers. Kailangan same sila. Okay? Okay, so yun yung shortcut. Pero yung long cut, ito yung long method na proton, neutron counting. Okay? Pero gawin na lang natin ganito ha. Yung number sa top and sa bottom, kailangan same lang. Okay?
So let's try to do it here. Okay, so for example, we have 212 polonium. Okay, we have 212 polonium, 208 lead. So ano daw kaya ito? Ano yung number dito? Ano yung number dito? And what will be the symbol there?
Ito yung question mark. Ano yung number dito sa taas? Ano yung number dito sa baba? Para maging balance yan. Okay? Ano gagawin mo? Kung ito 212,
212 yung taas. Palitan ko yung color. So 212 yan. So kailangan pag pinag-add ko to, 212 din. So 208 plus
what is equal to 12? Ano yan?
4, di ba? 212 plus 4 is, ayun, 208 plus 4 is 212, di ba? Okay. So dapat 4 yung ilalagay ko doon.
Okay? So 208 plus 4 is 212. So 212 to, 212 na to, balance na yung taas. O yung baba, paano ibabalance? So, ganun din.
No? So ito 84. So, kailangan ito, pag pinag-add ko yung dalawang numbers na to, 82 plus blank is 84. So ibig sabihin, ano yung add ko sa 82 para maging 84? Edi 2. Okay, para siya ay maging 84.
Okay? So, ibig sabihin, ang missing particle natin ay may mass na 4, may proton na 2. Okay? So, anong element yon? O, tingin ka sa periodic table. Ano yung element number 2? Zoom in natin. Ano yung element number 2? Helium. Okay? So, yun, lalagay mo dito sa symbol niya dito. Helium. Kasi, ang kanyang atomic number ay 2. Ito yung atomic number. Ano yung second element sa periodic table? Helium. Okay?
So lalagay mo dito, helium.
So, the missing particle here is question mark. Isang way to write helium.
You can write it as 42 alpha.
Okay? Because the alpha particle is helium. Okay? So, yan. 42 alpha. So, ito yan. Ayan. Helium or 42 alpha. Helium yan. Okay?
So, ganun. That's how you balance it. Madali lang.
Bigyan ko pa kayo isang example para pag may question, mag-message kayo ha. Okay. Para aware ako. Tuloy-tuloy lang ako eh.
Okay. So, ganun lang ha. You balance the numbers
On the top, you balance the numbers on the bottom. Okay? Tapos, para malaman mo kung ano symbol niya, tignan mo lang anong element number yan. Okay? Kunwari, 3 yan. Edi 8 yan. Oxygen yon. Edi letter O. Okay? So, ganun gagawin niya lang.
Okay. Let's try another example. Here, we have cesium 137,
Then we have barium 137.
okay?
Let me rewrite this.
Ganito gagawin niya.
Isulat nyo na pag ganyan para mas madali.
Box.
Okay? So, ganyan yung format pag nagsasagot tayo. So, balance natin yung top.
Okay, so top 137.
Dito. 137 na yan eh. May i-add ka pa ba? Eh di wala. Wala ka nang i-add. No? So, 137 na ito. Ito, 137 na. So, wala kang i-add. So, 0 yan. Okay? 0. Okay. So, ibig sabihin yung mass nun ay 0. So, anong particle kaya to? So, it could be a positron or electron. It could be a positron or electron. Kasi nga, sabi ko nga sa inyo, yung electrons, wala siyang mass. Virtually, walang mass. Okay? So, kapag 0 yon, most likely, electron yan o kaya positron. Okay? Okay. So, yan. So, 137 yung taas. 137 na to. 137 plus 0, 137. Sulat ko dito. Okay. Ayan, so balance na yung taas. O yung baba naman,
We have 55 dito. Ito. Kailangan mag 55 to. So, 56 plus something equals 55.
ano yung add mo sa 56 para maging 55? Negative 1. Okay. Negative 1 ilalagay mo.
Negative 1.
Okay. So, 56 minus 1 is 55. Okay. So, ibig sabihin, balance na yung protons natin. Medyo weird, no? Pero ganun talaga. This is how nuclear science works. Okay. So, ano to? 0, negative 1. Ano yung symbol niya?
So, this is a beta particle or electron. Okay. So, paano ko nalaman yun? Nandito yun sa table na pinascreenshot ko sa inyo. Ano?
0, negative 1e. That's electron or beta particle. Kung positive 1 yun, edi positron yun. Okay. So, ito yan.
So, yan. So, the question mark here is 0, negative 1, E. Or 0, negative 1, beta. Ganun lang. So, that's how you balance nuclear reaction.
Bilangin mo lang yung nasa taas, bilangin mo yung nasa baba. Yan. Kapag equal sila, balance na yan. So, ano yung mga symbol niya?
Ang symbol niya, pwede tignan mo periodic table o kaya
tingin ka dito. Okay? Pag negative 1 yung nasa baba, electron yun. Pag positive 1 yung nasa baba, positron yun. 0 yung nasa baba, neutron yun. Okay? Anything else ay nasa periodic table. Okay? So that's how you balance nuclear equations. No? Okay, so ayan, medyo marami kayong gagawin. 5 lang. Madali lang yan. Ha? Okay. So bilangin mo yung nasa taas, bilangin mo yung nasa baba. Add mo lang yun. Kailangan equal. Okay? So, this is how you balance nuclear equations. Okay? If you want to confirm kung balance yan, edi bilangan mo yung proton, neutron. Okay? Pero di ko na gagawin yan. Okay? So, kayo na bahala magbilang ng protons, neutrons. Then, makikita nyo balance na yan. Okay? So, this is the shortcut. Balance the masses and balance the atomic number. Ganun lang. Okay? So, this will be your prob set, no? Prob set yan. Madali lang yan, add lang yan. No? Yung mga question mark, hanapin nyo yan.
you write the symbol as this.
Ayan, ito yung mga question mark.
Ano yan? Ano yan? Ito. Ayun. Ayun. Ayun.
So, ano yan? Fill in the blank lang yan. Okay? So, bilangin mo yung mga number sa taas, bilangin mo yung mga number sa baba. Ganun lang. Okay. What will be the symbol? Yan o kaya. Okay. So, that's how we balance nuclear equations. Okay. Yun na yan. Yan lang yan. Tapos na tayo doon. Let's proceed with the next one. Okay. By the way, kung medyo foggy pa siya, no, you can rewatch the video naman. Okay, panoorin nyo na lang ulit. Okay, so next one, let's proceed to nuclear stability. No? Okay. So in this slide, may 4 forces of nature tayo. Okay, we have the gravity, electromagnetic force, weak force, and strong force. Siguro alam to ni Franklin kasi na-discuss ko to sa physical science, 'di ba? Ito yung first topic natin So these are the fundamental alam mo na. O sige nga, ano
sir.
tong gravity?
Hindi po, hindi nga.
Alam mo, pero naalala mo to, 'di ba? Ito
Apo.
yung dami yung sinulat sa board nun. Okay. So, ito yung fundamental forces of nature. No? The gravity. Ito yung reason bakit tayo ay hindi lumulutang. Okay. Electromagnetic force. Ang sabi lang nito, positive attracted sa negative. Okay. And then, weak forces, ito yung dahilan ng nuclear reactions. Mamaya kwentuhan natin. And the strong forces, this is the one that holds the nucleus. Okay. So, imagine nyo yung atom. Ba't pala picture ng atom muna nilagay ko? Kasi nasabi ko na agad yung dahilan sa nuclear stability. Anyway, kunwari wala kayong idea dito sa slide na to. Imagine mo yung atom, di ba? Yung atom natin. Ganito yung idea ng itsura nun. Okay.
You have the protons, you have the neutrons, di ba? Itong black, ito yung proton, ito yung neutron, then around it you have your electrons, di ba? Okay? So, di ba ganun? Proton, neutron sa gitna, electron nasa paligid. So, siguro magtataka kayo, no? Ang neutron, 0 yung charge, no? Ang proton, positive 1 yung charge. So, ibig sabihin, yung nucleus natin, unstable. Bakit siya naging unstable? Kasi, puro positive 1 charge yung nasa loob niya. Yung neutron, 0 charge niya. Pero yung protons, positive 1, no? So, magtataka siguro kayo, no? Imagine nyo, kunwari, anong element kaya? Kunwari, ito, radon. 86 yung proton niya. So, isipin nyo, 86 na positive charges yun nasa loob niya, nasa loob ng nucleus. Hindi ba unstable yun? Unstable yun, dapat, no? Kasi, puro positive. Ano alam natin sa mga positive? They repel. Yun yung sabi ng electromagnetic force, no? Sabi ng electromagnetic force, yung positive attracted sa negative. Kaya nga yung electron, naka-orbit yan. Okay? Kasi positive yung nucleus, negative yung electron, so that's why nandun siya. Kasi attracted sila. Electromagnetic force yan. Pero ano sinasabi ng positive sa positive? Magre-repel yun, di ba? Di ba may mga magnet, pag parehas positive yun, tatalsik yun. Bakit ganun sa atom? Hindi ganun. Kasi tignan mo, mayroon tayong gold, no? Ang gold, ilan yung protons niya? 79, ang dami. Pero ba't di siya tumatalsik? Ba't di tumatalsik yung mga protons, no? Ang dahilan nun ay yung strong force or the strong nuclear force, no? So itong strong nuclear force, ito yung puwersa ng nature that holds the nucleus together, okay? So kumbaga, ito yung rubber band ng nucleus, no? So imagine mo, papel yan, isang bungkus ng papel. Okay? Ibilot mo yan. Kunwari ito. May isang rim ako ng papel dito kasi ito yung dito ako nagna-note sa grad school. Hindi uso notebook eh. Kunwari, ito, papel na to. Kunwari, ito mga proton, neutron. Bibilot ko to kasi nasa nucleus sila, kailangan ipit na ipit sila eh. So, iipitin ko sila. Ayan. So, ayan, binilot ko na yung aking protons, neutrons. Di ba alam natin, pare-pareha silang positive charge, di ba? Except for neutron. So, ano mangyari? Ayun. Tatalsik sila. Yung papel nga tumatalsik, dapat yung nucleus tumatalsik din. Kasi pare-pareha sila ng charge eh. Di ba? Pero bakit hindi ganun sa atom, no? Kasi, ayan, tumalsik na naman yung papel ko. Bakit yung atoms natin hindi tumatalsik, no? Kasi nga may rubber band. Ang rubber band na 'yon, tawag doon nuclear force, a strong nuclear force. Okay? So the strong nuclear force is just like a rubber band dito sa aking papel. So kapag nilagyan ko ito ng rubber band, which is wala ako, itong charger na lang. Kunwari, ito yung strong nuclear force. Pag nilagay ko yan dyan, it holds the nucleus together. Okay, so it holds the nucleus together. Ayan. So, yan yung reason bakit yung ating atoms ay stable because of the nuclear force. No? Wait lang, babalik ko lang itong papel natin. Ayan. So, the reason why, because of the strong nuclear force or the strong force, it binds the nucleus of the atom. No? So, kaya yung mga positive, nagdidikit-dikit. No? However, there is a limit. No? May limit sa rubber bands. No? Di ba yung rubber band natin, napuputol yan. Okay? So, ganun din yung strong force. No? So, not all the time ay malakas yan kahit strong yung pangalan niya. Okay? So, that's why there are some elements, no? Kunwari, marami na masyadong proton. For example, uranium. Okay? So, for example, uranium, masyado na maraming protons na nagre-repel na sila. So, ang nangyayari, yung strong force, medyo humihina na.
That's why it starts to disintegrate into smaller particles, no? Naglalabas-labas na siya ng mga alpha particles, no? So, ganun yung nangyayari sa uranium, no? Kaya siya radioactive. Okay? Kailan nagiging radioactive yung isang bagay? Kapag masyado na maraming protons, okay? Sobrang daming protons, hindi na masyado kaya ng strong force i-combine sila. Kaya nangyayari, tumatalsik-talsik na yung ibang particles, no? Okay? Tumatalsik-talsik na siya. Okay? So yan yung strong force. Yan yung reason for nuclear stability. However, sabi ko nga sa inyo, if you have particles that have so many protons, hindi na niya kaya minsan yan. That's why some elements are radioactive, no? So anong elements ba yung mga radioactive elements? Mostly yung mga atoms na nandito sa babanto. Okay. So these are the elements that are radioactive kasi tignan mo, ang dami na nilang protons, no? Sobrang dami na. Kaya hindi na kaya ng rubber band, no? Hindi na kaya ng strong force. Ayan, tumatalsik-talsik na yung mga particles, therefore radioactive. Okay? Ano namang ganap na itong weak force? So itong weak force naman na ito yung dahilan kung bakit nagkakaroon ng nuclear reactions, no? Okay? So medyo ano pa to, medyo marami pang details itong weak force pero hindi ko na i-discuss kasi masyado na siyang physics, no? Masyado na siyang masyado na siyang maraming nalalaman. Okay? Masyadong physics na to kaya di ko na sasabihin. Okay. Pero ito yung dahilan, that's why we have positron emission, electron emission. Okay, so kumbaga sila yung dahilan ng mga nuclear reactions and smaller particles. Okay? So, yan. Strong force naman, siya yung nag-hold ng nucleus. Pero again, hindi lahat ng rubber bands matibay. So, ibig sabihin, kapag masyado ng maraming protons na, hindi na niya kakayanin minsan. That's why an element becomes radioactive. Okay? Kaya nga, di ba mapapansin nyo, di ba gumagawa sila ng new elements? For example, the organeson. Wala pala dyan. Punta tayo sa Google. Pakita ko sa inyo kung ano yung punto ko sa sinasabi ko. Wikipedia tayo. Ito, organeson. Wait lang. For example, this is organeson. Ito yung last element sa periodic table. I believe this is atomic number 118. Ayan, atomic number 118. So, ibig sabihin 118 yung protons niya. Okay? So, ano epekto nun? Di ba marami ng positive particles sa nucleus? So, ibig sabihin, hindi na kaya ng nuclear force i-hold siya. That's why, tignan mo yung half-life niya. 0.69 milliseconds, no? So, ibig sabihin nun, at 0.69 millis, kalahat of other particles. So, kung sa rubber band yun, wala na. Tumalsik na yung ibang atoms kasi hindi na kinaya ng rubber band. Okay? So, na-convert na siya into other elements, no? Other smaller elements. Okay? Kasi nga, ang dami na masyadong proton. Hindi na kaya ng nucleus. Okay? That's why its existence is short-lived lang. No? Masyadong mabilis yung existence niya. 0.69 milliseconds lang. Okay? Ibig sabihin nun, if you have 1 gram of organeson, after 0.69 seconds, 0.5 grams na yan. The next, 0.69 millisecond, 0.25 grams na lang yon. Then later on, kalahati until virtually ubos na siya. Okay? So, ganun kabilis nawawala yung mga elements na malalaki yung protons. No? Kasi nga, hindi na kaya ng nuclear force i-hold, ng strong nuclear force i-hold yan. Okay? So, nag-disintegrate na siya biglaan. Okay? Pero compare mo yan sa hydrogen. Hydrogen. Tignan mo yung hydrogen. Helium na lang, helium. Okay. So, tignan mo. Walang sinabi about half-life kasi sabi niya, stable siya. Okay? when it's pag sinabi stable, not enough yung repulsive forces para masira yung atom. Okay? Kumbaga, malakas yung rubber band, hindi siya masisira, kaya stable siya. Pero ang idea nga, pag dumadami na yung protons, hindi na kinakaya ng strong force. No? Sasabog na lang yung atom. Okay? That's why they become radioactive. Okay? So, yun yung reason that may mga radioactive elements tayo. Okay? So, that's because of the strong, hindi niya kaya yung dami ng protons, radioactive na yan. Okay? So, ito pa. So, the existence of stable nuclei is due to the nuclear force. No? So, imagine nuclear force is a rubber band that holds the nucleus. No? Pero may limit yan. Okay? So another thing with nuclear stability is that it is predictable. Okay? So predictable siya. 'Di ba yung electrons, siya yung reason bakit tayo may mga noble gases. And noble gases are stable. They are unreactive. 'Di ba? Okay? Hindi sila nagre-react with other chemicals generally. Okay? So sa nucleus may ganun din, no? 'Di ba sa atoms kunwari noble gases, mali spelling ko ng gas. Pag noble gases, ano tayo? 'Di ba kapag nakumpleto mo yung s orbital, pag nakumpleto mo yung p orbital, stable na 'yan, 'di ba? Ibig sabihin, there is a number of electron equivalent to a stable atom in terms of electrons, 'di ba? Okay? Sabi dito, shell model of nucleus is a nuclear model in which proton and neutrons exist in levels and then they are stable at some number. Okay? So ano yung mga numbers na yon? Ito. Rules in predicting nuclear stability. Number 1, nuclei that contain these numbers of protons or neutrons are generally more stable than others. Okay? So ano meaning niyan? If ganito daw yung number of protons or neutrons mo sa isang atom, then masasabi mo na stable yung atom na yan. Okay? Katumbas to ng sa electron. Kasi for example, helium is 2. Neon is 10 nga lang. Okay? Ah, pero kapag nucleus, no, ito yung numbers na kailangan mo. 'Di ba kapag electrons 2, 10, 18, so on so forth. Kapag nucleus daw, ito daw yung mga numbers na special, no. If your atom has its protons or neutrons, they are more stable than the others. So tawag natin sa mga numbers na to ay magic numbers, no. So if you have magic numbers, then your atom is significantly stable than the others, no. Okay? So significantly stable siya compared to others if it contains the magic numbers. Okay? So by the way, ito ay ano pa lang, more on theoretical. Ang latest na basa ko dito sa journals ay inaalam pa nila bakit ito yung mga magic numbers, no? They are still learning about the nuclear shell model, okay? So wala pa akong masyadong mabibigay na info about bakit yan yung numbers na stable, okay? Kasi inaalam pa nila. But experimentally speaking, ito yung na-observe nila. If the element has these numbers, stable siya. In theory, inaalam pa nila. Bakit? Okay? Kasi recent lang yung nuclear science. No? Recent lang siya. Kaya marami pang kailangan malaman about it. No? Okay? So yan. So again, if your nucleus has this amount of protons, stable siya compared to the others. So mababasa nyo rin dito sa paragraph natin, this is similar with electrons kasi ang elements with 2, 10, 18, and so on electrons ay stable. Okay. Next one, nuclei with even numbers of both protons and neutrons are generally more stable than those with odd numbers. No? Bakit kaya, ano, bakit kailangan evons neutrons? Okay, it has something to do with the shell model then. And again, the shell model of nucleus is still being studied. No? Okay, basta ito yung observation nila. Okay, but the main reason why still is inaalam pa nila. Okay, so yan. So if you look for journal articles, they are still experiments ongoing with this one. Okay, so basta in theory ito. Next one, all isotopes of the element with atomic numbers higher than 83 are radioactive, no? So, ibig sabihin, kapag yung uh, atomic number ay greater than 83, which is, anong element yon? 83. If ang element mo ay greater than 83, bismuth, ibig sabihin, yan ay radioactive na. For example, polonium, okay? Polonium is a radioactive element na ginagamit din to sa nuclear power plants. Okay? Radon is a radioactive element. Okay? And everything greater than 83 is radioactive, generally speaking. Okay? So yan. Also, ito medyo may exception lang. If you have technetium and promethium, although ang kanilang atomic number ay less than 83, they are radioactive then. Okay? So mapapansin mo medyo complicated yung rules in predicting nuclear stability kasi nga hindi pa siya fully developed compared sa electrons. Yung electrons kasi observable. Pero yung mga neutrons, protons, mahirap i-observe yun eh. In general, kapag i-observe mo yun, fraction ng second lang, wala na sila. Okay? Because of the strong nuclear force. No? Yun. And the weak nuclear force. No? So, yan. So, medyo inaalam pa nila to. Okay? So, again, ito yung mga rules in predicting nuclear stability. Take note of the exceptions, but may exceptions kasi nga, medyo hindi pa nila naaalam talaga hindi pa nila nakikita yung bigger picture. Okay? So ito yung summary natin, the rules in predicting nuclear stability. If you have the magic numbers 2, 8, 20, 50, 82, 126, yan ay stable. Okay? If ang protons, neutrons ay even, they are more stable than those who do not have those. No? Number 3, any elements greater than 83, greater than bismuth, is radioactive. No? And isotopes of technetium and promethium are radioactive despite na sila ay less than 83. Okay? So, pakit-note na lang yan. Okay? So, ito yung observed nila. Ito yung mga observations nila. Papansin mo, if you have even protons, even neutrons, mas maraming stable isotope compared to those who are a mixture of odd, even, or both odd. No? Okay? So, mas marami kapag even kaysa sa odd. No? Okay? So, ano kaya possible reason dito? Possible reason dito is kapag 1-to-1 yung ratio ng proton-neutron, parang may cushion na. Para siyang may cushion na. Okay? So, yan. Parang for example, kunwari ito. Kunwari, for helium, you have ito, mga protons. Okay, so yun yung mga protons at yung mga neutrons. Kumbaga, parang idea lang dito is kapag even number yung iyong neutrons, no, and yung protons mo, parang equal yung forces nila, no? Equal yung cushion na nagagawa ni neutron for the protons not to react, no? Imagine nyo yung neutron, parang unan yan, no? Okay, so that yung dalawang magnet, hindi sila mag-repel. No? Yung dalawang positive, di sila magre-repel. Okay, so kung even yung numbers nila, then stable sila. Okay, pero inaalam pa nila to. No? Okay, so yan. So anyway, so if you graph your elements, okay, if you graph your elements here sa ating graph, no, so we're in the vertical axis you have the number of neutrons, and in the horizontal axis you have your number of protons. Mapansin nyo, this is the band of stability, no. Ito yung band of stability which makikita natin yung stable nuclei. Itong red dots na to. Okay? Itong red line naman na ito, Itong red line na ito, this is the ideal band of stability. Di ba sabi ko nga dito, kung ilan yung protons mo, ganun din dapat karami yung neutrons. Parang unan kasi yan, no? Okay? So, ideally, 1 to 1 yung ratio niya. Isang proton, isang neutron, dalawang proton, dalawang neutron. Okay? Kaya stable yung, yung helium dahil doon. Okay? However, as you can see, if your element becomes bigger, okay, kapag lumalaki na siya ng lumalaki, the band of stability deviates the 1 to 1 ratio. Ito yung 1 to 1 ratio, yung red line. Yung band of stability, yung dots. No? As you can see, it starts to deviate, no, from the 1 to 1 ratio. Okay? Bakit kaya? Ang possible explanation dyan is kapag masyado na maraming positive particles, mas marami ng unan yung kailangan to repel them. Mas marami ng fusion ang needed para hindi sila mag-react to one another. Okay? Hindi sila mag-repel. So that's why it starts to deviate, no? The greater the number of protons, the more neutrons you now need, no? Para mas maging stable sila. Okay? So, yan. So, when your Z is equal to 20, when your atomic number is greater than 20, then it starts to deviate from the 1 to 1 ratio of neutron and proton. Okay? As the number of protons increases, the neutron to proton ratio increases to about 1.5. Okay? Okay? So, ang idea lang dito is that, ayun nga, no, kapag lumalaki na yung nucleus mo, mas marami ng neutrons yung kailangan to stabilize the atom. So, kapag onti lang yung onti lang yung protons, onting neutrons lang din kailangan. Okay? So, yan. Paki-take note na lang that the trend starts to deviate from ideality at Z equals 20. So, Z is the number of protons. For example, yung calcium, yan, hindi na siya 1 to 1 yung ratio. Okay? So, ayan. Let's try to do this activity na with all those stuff in mind kung naaalala pa. Okay. Let's predict each nuclide if they are stable or radioactive. No? So, we have the 3 examples here. Turo ko kung paano gagawin dito. Okay, so, we have 284 polonium, 209 bismuth, and 3919 potassium. Okay. So, alamin daw natin kung stable sila or not. Kung stable sila, edi good, hindi sila magre-react. Kapag unstable sila, paano mo nasabi? Okay? So, ano ba kailangan natin dito to predict whether they are stable or not? Itong rules lang na sinabi ko. If they possess the magic numbers, stable yan. Kapag even yung kanilang protons, neutrons, stable yan. Pag less than 83 yung kanilang atomic number, stable yan, except technetium and promethium. Okay? So, ganun gagawin natin. Check mo yung proton, neutron, then see if you can see the magic numbers or not. Okay? Okay, so let's start with polonium. Proton for polonium is 84. Neutron for polonium is, what's 208 minus 84? Subtract ko lang. 208. 124. So the proton is 84. The neutron is 124. Okay? So, paano natin malalaman kung ito ay stable or not? No? Okay, ganito. Siguro iisipin nyo, even yung proton, neutron, no? Even yan. Yeah. So, ibig sabihin ba nun, stable siya? Pwede. Pero, take note na sinabi rin natin kanina, kapag greater than 83 yung protons, radioactive yon or unstable. Okay. So, dito may tunggalian dito, ha? Paki-take note yung mga sinasabi ko. Okay. So, yes, ideally, kapag even sila parehas, stable sila. However, sinabi din natin, kapag greater than 83, unstable na talaga sila or radioactive. So, sino susundin natin doon? Yung even-even or yung greater than 83 ay unstable? Ang sagot natin doon ay yung greater than 83. Yun yung susundan natin. Okay? So, ganun ha. Okay. So, medyo case-to-case basis yung gagawin nyo dito.
Kapag greater than 83 yan, yung protons, even though na even yan, unstable yan. Okay? So, this is unstable. Bakit? Kasi Z is greater than 83. Okay? The number of proton is greater than 83. Okay? So, yun ha. Although even yan, mas mag-hold true pa rin ito. Kasi ito yung pinaka-general statement. Basta greater than 83, radioactive. Okay? Paki-take note yan. You have to weigh the rules, no? Sino masusundin? Masusundin mo yung greater than 83. Okay? The next one, we have bismuth. We have bismuth, 83 yung protons niya. Neutron 209 minus 83. Subtract ko lang. 209 minus 83, 126. Okay? So, sundin natin, Z is equal to 83. So, ibig sabihin, stable pa yan. Kasi sabi nga natin, kapag greater than 83, unstable na talaga. Okay? So, ito pwede pa ito maging stable kasi 83 siya. Below the threshold. So pwede pa ito maging stable. What else, no? It has this number, 126. Ang 126, this is a magic number. Okay? So kung maalala nyo kanina, sinabi natin na 126 is a magic number. Yan na. If it contains protons or neutron equal to the magic number, stable yan. Okay? So ibig sabihin, basta may 126, stable. Okay? Ganun. So this is stable. Stable kasi Z is equal to 83. Okay? And then, may magic number. May magic number. Okay? Basta may magic number dyan, stable yan. Okay? Next one, we have 39 potassium. Proton, neutron. 19 yung proton. 20 yung neutron. Okay? So, 20 yung kanyang neutron. So, may magic number ba dyan? O, tignan natin kung may magic number. Ayan, sabi. 20 is a magic number. 28, 20, 50, 82, 126. So, 20 is a magic number. Okay? So, ibig sabihin, since may 20 tayo dyan, stable yan. Stable yan. Stable. Kasi, may magic number. May magic number. Tsaka yung proton is less than 83. And then less than 84 bale. Kasi 83 yung maximum limit ng stability. Ayan. Okay, so ganun lang. So stable yan kasi may magic number. Pero bakit kaya sabi nila no, yung saging natin, radioactive daw yung saging. Okay, radioactive yung saging. Kasi 'di ba may potassium 'yon. Okay. May potassium yung saging kasi. And yung form ng potassium natin sa saging ay potassium 40. Sagutan ko na to. So 40, 19. Okay. Alamin natin yung proton, neutron yan. So proton is 19, neutron is 40 minus 19, 21. Tama ba? Okay. Yeah, 21. Okay. So, yan. So 19 yung protons, 21 yung neutrons. Okay. So, ito yung mga nasasaging kasi potassium 40. Okay. Bakit siya naging radioactive? Kasi parehas siyang add, diba? Sabi natin, kapag add, yun ay unstable talaga. Okay. Pag add, onti lang yung stable. So, generally, they are unstable. So, ibig sabihin sila ay radioactive or unstable. Kaya yung saging natin, since meron kang potassium 40 doon, radioactive yon. Pero not so radioactive, no? Kasi pwede ka pa rin kumain ng saging, no? Pwede ka pa kumain ng saging, hindi ka mamamatay sa radiation sickness. Hindi ka madideform. Okay. Kasi onti lang naman yung potassium 40 doon sa saging. Okay. Hindi naman ganun karami. Okay.
Ayan. So, ganun lang. So, ibig sabihin, pwede pa rin kainin yan. And kung gusto mo magkaroon ng side effect ng pagiging radioactive ng potassium, you need to eat tons of saging. O, hindi ka mamamatay sa radioactivity nun. Mamamatay ka sa kabusugan. Okay? Kasi toneladang saging pa kailangan kainin mo bago ka maka-feel ng symptoms of radioactivity. Okay? So, mamamatay ka muna sa kabusugan bago sa radioactivity. Okay? So, ibig sabihin, safe kumain ng saging. Okay? So, ganun lang. Sa radioactivity kasi, ang harm ay based sa kung gaano karami. Okay? Kung gaano karami yung radioactive particles. Kung onti lang naman, okay lang. Okay? That's why nga, meron mga radioactive materials sa bahay eh. 'Di ba alam niyo yung mga smoke detector? May americium 'yon. Okay? Americium is one of a radioactive element. No? Okay? So, americium ay isang radioactive element. Pero andun siya sa smoke detectors. No? Okay? So, hindi ka na mamamatay sa radioactivity agad. No? Basta onte, okay lang. Okay? Katulad lang ng sa saging. No? Hindi ka mamamatay pag kumain ng saging. Okay? So, although radioactive, pero not that much. Okay, maganon din naman sa araw eh. Tignan mo, lumalabas tayo sa bahay. May radioactivity na nilalabas yung universe sa atin in the form of cosmic microwave background, no? Radiation. Tsaka yung mga UV rays, no? Ayan, no? Radioactivity yan, no? Pero hindi naman tayo namamatay, no? Buhay pa rin tayo. Okay? So, ibig sabihin, basta onti lang yung amount, safe. No, safe yan. Ngayon, mag-weigh in sa tatlong rules. No? Pag may magic number, stable yon. Pag greater than 83, unstable yon. Kapag even, stable yon. Okay? Pero you have to weigh among the three. Sino yung masusundin mo? Masusundin mo yung greater than 83, no? Pag greater than 83, unstable talaga sagot mo nun dapat. Okay? Pero kunwari, what if hindi po siya greater than 83? Doon na pwede pumasok yung magic number. Okay? Pag hindi siya pasok sa magic number, doon ka sa last one. Yung even, odd, so on, so forth. Okay? So, ganun yung hierarchy ng pag-predict, no? Tignan mo muna, if less than 83, pag less than 83, pwede maging stable yon. Susunod na titignan mo yung magic number. Pag may magic number, edi good yon. Pag wala, tignan mo kung even. Pag even, stable yon. Pag odd, unstable yon. For example, yung nangyari sa potassium. Odd yan. Less than 83 yan. Okay. Pero radioactive siya. Kasi nga, odd yan. Unstable yan. Okay? So, ganun yung gagawin mo dito. Ganyan yung gagawin niya for the rest of the items. Ay, sasagutan ko pa isa para saktong 5 din yung nasa prop set. Sagutan ko pa to. Gallium 7131. Okay. So, for gallium 7131, okay. So, proton, neutron, proton is 31, odd yan. Neutron is 40. 40, di ba? Okay. So, yan. So, ano yan? So, is this stable or not? Tingin tayo sa mga rules natin. Magic number, kahit di mo kabasado, okay lang yan. Okay. So, ito yung magic number, 28. Okay. So, yan ay 28. 20, 50, 82, 126 na. Okay, so wala siyang magic number. Less than 83 siya. Okay. Tapos ang kanyang combination ay odd-even. Okay. So, ano pwede natin isagot dito? So, we can say na ang gallium, radioactive ba siya agad? Not really. Okay? Not really. Okay? Kasi, ating C4, okay, so ibig sabihin medyo okay pa siya.
Wala siyang magic number. Tapos odd even pa yung kanyang combination. No? Odd even yung combination niya. So, ano pwede na sabihin dito? Ito ba ay unstable? Pwede siya maging unstable. Okay? So, pwede siya maging unstable. Okay? Paano natin nasabi na unstable siya? Kasi nga, ito, hindi niya nasunod ito. Okay? So, relatively unstable siya. Okay? Relatively unstable. Okay? So, relatively unstable lang. So, ganun lang yung criteria natin. So, sundin mo muna to. Okay, yan. Pero ito, wala siya magic number. It's odd even pa. So, XX yan. So, unstable yan kahit pa paano. Okay? So, ganun lang. Ang ideal kasi ay even-even. Okay? Pero ang nangyari sa kanya, odd-even. So, may chance na siya ay unstable. May chance na siya ay unstable. Kasi wala rin siya magic number. Okay? So, ganun lang gagawin mo. So, ito muna. Pasok siya doon. Okay. Pero dito sa dalawa, hindi. So, you can say na medyo unstable siya. Okay? Medyo unstable. So, ganun lang. So, ganun yung gagawin nyo, ha? Check nyo to. Ito. Pag dalawa yung hindi pasok, sabihin nyo unstable na. Okay? Pero kapag ito, mali agad siya dito, unstable na talaga yon. Okay? Kasi any elements greater than 83 is really unstable na. Okay? So, ganun. So, ganun lang gagawin nyo, ha? Bilangan nyo protons, neutron, then follow this checklist. This one, pag hindi sinunod to, radioactive agad. Pag sinunod to, pero yung dalawa, hindi, unstable agad. Okay? So, ganun lang gagawin nyo. Okay? Next one, we have the types of radioactive decay. Okay. So, types of radioactive decay, for each nuclide, iba-iba yung kanilang way of disintegrating. Okay? Iba-iba yung way of nuclear reactions nila. Okay? So, marami tayong forms of radioactive decay, and for each element, meron siyang sinusunod na. Okay, for example, alpha emission or the removal of helium from the nucleus of the atom. Kailan to nangyayari? Ang alpha emission, nangyayari to when your nuclide, this is common when your nuclide has Z greater than 83. Ibig sabihin, greater than bismuth yung element mo. For example, polonium. Okay, so it can start undergoing alpha emission. Okay. So again, alpha emission is common when your Z or your proton number is greater than 83. So ano yung nagiging product kapag alpha emission? The alpha particle or helium. Okay, so basically, ito yung element mo, babawasan mo lang ng 4-2. Alpha emission yan. So this is the emitted alpha particle. Okay, so that is the emitted alpha particle. So you must say, ito ba ay stable or not? Stable ba to? Hindi pa rin siya stable. Kasi greater than 83 pa rin siya. So ibig sabihin, this can still undergo alpha emission. So ganun yung mangyayari, no? So tuloy-tuloy na alpha emission until maging 83 yung kanyang atomic number or less. Okay? Kasi kapag greater than 83, mag-alpha emission talaga yan. Okay? So ganun. Okay, so for example, let's look at this graph. So at this graph, radioactive decay series, mapansin mo, ito yung 83. Pag greater than 83, what happens? Puro alpha emission yung nangyayari. So alpha emission, alpha emission, alpha emission. Okay, so pag greater than 83, the common mode of radioactive decay is alpha emission. Okay, puro alpha emission until pumasok siya sa 83. Okay, pag hindi pa siya 83, alpha pa rin. Okay, so yan. So this alpha emission.
Beta emission naman, this happens when ano ba sabi dito? So, kailan nangyayari yung beta emission? Beta emission happens when when your nucleus has more neutrons than necessary. Okay? So, kapag mas marami siyang neutrons kaysa sa kailangan, dun siya nangyayari. Paano mo ba malalaman yung required number of neutrons? Ganito lang yun. For example, ano kaya pwede gawin yung example? Okay. Ito yung stable form of ito yung stable form of carbon 12. Okay. So this is a stable form of carbon 12. Paano mo malalaman yung stable form of carbon? Gagawin mo ganito lang. Tingin ka lang sa periodic table, i-round off mo yung mass to whole number. Itong 12.011, gawin mo 12. Okay. So stable version niya yung 12. Okay. Yun yung shortcut doon. Pero we have carbon 14 here. Okay. So, malalaman mo that this carbon 14 will undergo beta emission if you want your proton to neutron ratio ay bumaba. Neutron to proton ratio ay bumaba. Okay. So, tignan natin yung neutron to proton ratio na ito. So, this is 6. This is also 6. So, neutron over proton is equal to 1. Okay. So, proton nito 6 to 8. So, 8 over 6. Ano ba yung 8 over 6? 8 divided by 6. 1.33. So, if the neutron to proton ratio is high than the stable, magbe-beta emission ka. Okay? So, this is higher. No? 1.33 is higher than the stable na 1 neutron to proton ratio. So, kapag mataas yung NP ratio, mag-undergo ka ng beta emission. Okay? So, ganun yan. Paano mo pala malalaman ulit kung ano yung stable form of nuclide? Ganito lang gagawin mo. Para malaman mo kung anong stable form of nuclide mo, you have your periodic table, i-round off mo yung mass. For example, carbon 12, ayan, C12. Kasi pag ni-round off mo yung mass, 12 yan. Kunwari, boron, edi boron 11, yun yung stable nuclide niya. I-round off mo lang. Aluminum 27, silicon 28, phosphorus 31, oxygen 16. Okay. So, you just round it off. Okay. Para malaman mo kung ano yung stable nuclei. Yung mass i-round off mo so that yung iyong exponent dito ay naka-whole number. So, ayan. So, beta emission happens when the neutron to proton ratio is higher than the stable form. Okay? So, ayan. So, maglalabas siya ng beta emission. Maglalabas siya ng beta particle. Positron emission naman is yung kabaliktaran. Okay. So, positron emission happens when your NP ratio is low than stable. Maglalabas ka ng positron kapag ganun. NP ratio is low. Okay? For example, we have technetium. 9543. Technetium. Ang stable form ng technetium ay, natingin tayo sa periodic table. Technetium. 98.9, round off 99. Okay. So, 99.43. Neutron-proton ratio. So, this will be 43. Yung neutron ay 99 minus 43. 56. 56 divided by 43. 1.30. Okay?
Dito naman sa 95 technetium, so neutron to proton ratio, alamin mo, 43 protons, neutrons, 95 minus 43, 52. Okay? So 52 divided by 43, this is 1.21. So as you can see, this one has lower neutron to proton ratio than the stable. Okay? Kasi yung stable 1.30. Tapos itong 95 technetium natin, ang neutron to proton ratio niya ay 1.21 yun. So in order for this to be more stable, it has to undergo positron emission. Okay? So when the neutron to proton ratio is low, then you have to undergo positron emission. That is different with the beta emission. Okay, pag beta emission, neutron to proton ratio is higher than the stable. Again, paano ko nalaman yung stable? Sabi ko, i-round off yung masses. For example, technetium is 98.9, round off mo yan 99, yun yung ginamit ko, 99 technetium. Yun yung stable. Okay? So, ganun lang. Pag napansin nyo, mas mababa to kaysa dito. Ano yan? Positron emission yan. Okay? Next one is electron capture. Okay. So, kapag electron capture, saan ba to similar? So, this is similar with, I think, positron emission. Dun siya similar. Okay. So electron capture is similar with positron emission. Okay, so this is similar when NP ratio is low, slower than the stable. So dun mangyayari yung electron capture. Okay, so what will happen here sa electron capture? Bababa yung number of proton, so yung ratio nila ay tataas. Okay. For example, let's compare potassium, teka lang, potassium, ano yung stable niya? Potassium 39. Okay, so the stable form of potassium is 39. Ang isotope natin dito ay 40. Okay. Paano ko ulit nalaman yung stable? Tumingin lang ako sa periodic table. 39 yung mass niya. Edi round off 39. Okay. So 39 yung mass number niya. Tignan mo yung neutron to proton ratio. So this will be 19. 39, 20 divided by 19. 1.05. Okay. Dito naman sa ating isotope, this will be 19, this will be 21. That's 1.11. Ay, sorry, hindi pala siya lower, pag higher pala. Sorry. Pagbabaliktad ko to parate. Yan. Hindi ko kasi nalalagay sa PowerPoint. Okay. So when the neutron to proton ratio is higher than the stable, doon nangyayari yung electron capture. So I'm sorry for that na. Baliktad pala ako. So yan. So mapansin mo, this is the neutron to proton ratio of the isotope. This is the stable. Higher siya. So it will undergo electron capture. Okay. So sorry for that. This is similar with, saan siya similar? With the beta emission. Okay. So ang beta emission kasi natin ay ganun din. Neutron to proton ratio is higher than the stable. Okay. So yun na lang mga i-note nyo. Okay. Ang gamma emission naman, basically walang magbabago. Okay. So ito yung gamma ray natin. Ang gamma symbol niya, 0, 0. So 0 yung neutron, 0 yung proton. So walang nangyari. So kailan lang nangyayari yung gamma emission? Ang gamma emission happens when your nucleus rearranges. Okay. Pag nagre-rearrange lang yung nucleus, doon lang siya nangyayari. Okay.
So, paanong rearranges? Di ba kunwari, tayo, yung bag natin, pag hindi siya magulo, di ba, shake mo siya para umayos. Ganon din yung nucleus ng atom. Okay? Kunwari, it just underwent a nuclear reaction. Mas medyo magulo yung arrangement ng neutron-proton. Mag-shake onti yun. So, para ma-rearrange yung nasa loob niya. Okay? And then, once na ma-rearrange yung nasa loob niya, it emits gamma rays. No? Okay? So, yan. Kapag gamma rays, walang magbabago. It just happens when your nucleus rearranges. Okay? Nagkakaroon lang ng rearrangement sa nucleus. And then we have the spontaneous fission. Ito naman spontaneous fission. This is the emission of many nuclides from one nuclide. No? For example, we have the uranium. No? So this is the uranium. Mapansin mo, it disintegrated into many particles. No? Okay. So we have this element, and neutrons. Okay. So ito yung spontaneous fission. Yung more than one yung napoproduce niya na elements. Okay. Even naman yan eh. So hindi naman kayo magpe-predict niyan. Okay. So again, in summary, paano mo malalaman kung anong type ng radioactive decay yung kailangan mo gawin? Okay. So malalaman mo kapag alpha emission yan, ito yan. Okay. So, malalaman mo kapag alpha emission yan if the Z is greater than 83. Okay? So, that's alpha emission. Kapag beta emission naman, malalaman mo yan kapag your NP ratio is too large. No? Okay. So, higher than the stable. Yan. So, yan. Paano mo malalaman yung stable? Tingin ka lang sa periodic table. Tingin ka lang sa periodic table, hanapin mo yung stable, round off mo lang yun. For example, beryllium, stable niya, and then 9, round off mo lang yan. Okay. Boron, 10.8, round off mo yan, 11. Okay, so 11 yung mass na stable niya. Okay. So, yan. Beta emission, kapag neutron to proton ratio is higher than the stable. Okay. Positron emission, this happens when the neutron-proton ratio is small, okay? It's lower than the stable. Electron capture, this is when neutron-to-proton ratio is higher than the stable, okay? So, ganun. Yan. By the way, kapag electron capture, yung electron ay nasa reactant side. No? Bali, susundin mo lang yung format. Alamin mo lang kung ano yung gagawin niya. Okay? So, gamma emission, kapag lang, may rearrangement lang. So, basically, walang magbabago sa element. Okay? So, ganun lang. Let's try to predict the radioactive decay dito sa ating items. Magsasagot ako ng dalawa dito. Then, predict natin. So, ibig sabihin yung dalawa will be your prob set. Yung dalawa, yung tatlo magiging prob set nyo. Sasagutan ko itong dalawa. Okay? Okay. So, we have calcium 4720. Ito yung ating isotope. Ano yung stable niya? Tingin tayo sa periodic table, calcium. I-round off mo lang. Okay, calcium 20, tapos ang mass ay 40. Round off mo 40. Okay. So, yun yung isotope natin. Ang stable, yung sabi sa periodic table, 40-20 calcium. So, kunin mo yung neutron to proton ratio agad. Ganun agad gagawin mo. Kunin mo yung neutron to proton ratio. Okay? So, proton ito, 20. Ito, 20. So, 1. Ito. Neutron ito, 27. Proton is 20. So, 27 divided by 20 is 135. So, as you can see, the neutron to proton ratio is large. No? Okay. So, the neutron to proton ratio is large. So, ibig sabihin, it's larger than stable.
So, ibig sabihin, it will undergo beta emission. Okay, so it will undergo beta emission. Pwede rin electron capture. Okay, so it will undergo beta emission. Ganun lang. So, compare mo lang yung NP ratio niya sa stable. Okay, so NP is this. Ito yung stable, 1. So, this is higher than 1. So, ibig sabihin, it will undergo beta emission. Okay. Another example will be aluminum 25. Aluminum 25. Ganun lang gagawin niya. Compare nyo lang siya sa stable. Paano mo malalaman yung stable? Nasa periodic table yan. Okay? I-round off mo lang yung masses. Okay? And emphasize ko para hindi makalimutan. Ito yung isotope mo, aluminum 25. Stable, hanapin mo sa periodic table. Ito yung aluminum. 26.9, round off mo yan. Ito 27. Okay. So 27 yan. So ganun gagawin ha. Para malaman yung stable, anong gagawin? I-round off. Okay. So yun, kunin mo yung neutron to proton ratio. Okay. So ito 13 sa baba. 27, 13, bali 14 to 12. Okay. So 14 over 13, 1.08. 12 divided by 13 and I 0.92. Okay, so as you can see, the neutron to proton ratio is low than stable. Okay, so the neutron to proton ratio is lower than the stable. So anong pwede niya i-undergo? Pwede siya mag-undergo ng positron capture. Positron emission. Okay. So it will undergo positron emission. Okay? So ganun lang. Ganyan na naman gagawin niya dito eh. So you have your you have this stuff here. You just compare it with your stable. Yung neutron to proton ratio nila, compare mo lang yan with the stable. Then kapag ito mas mataas, then ibig sabihin beta emission 'yon. Pag ito mas mababa, yan ay positron emission. Okay? Kapag ang Z naman is greater than 83, alpha emission yon. Okay. Ganun lang. Alamin mo lang. For example, ito, nitrogen 13. You compare it with nitrogen 14. Nitrogen 14 yung stable. Ito yung isotope. Compare mo yung kanilang NP ratio. Then, dun mo malalaman kung anong type ng emission yung pwede. Okay? So, ganun lang. Ito, sodium 26. Stable form ng sodium ay sodium 23. Adi, compare mo yung neutron to proton ratio. Uranium 237. You compare it with the stable form of uranium, which is uranium. Hindi ko kabisado yung mas eh. Sabi, the stable form of uranium is uranium 238. Meron ka dito 237. Alamin mo kung anong type ng decay yung gagawin niya. Okay? So, by the way, di ko naman itatanong kung ano yung equation. Basta alamin mo lang kung ano yung suitable form of decay na pwede niya i-undergo. Okay? Ganun lang. Okay? So, yun nga, yun yung ginagawa ng ating nucleus as it undergoes series of nuclear reaction. Okay? So, ganyan yung nangyayari sa nuclear power plants, no? So, kumbaga yung nucleus na yung bahala kung ano gagawin niyang process. Okay? So, ibig sabihin, alam niya kung anong decay gagawin niya. Kung siya ba ay magbe-beta decay, positron emission, electron capture, alpha emission, no? So, alam niya kung ano gagawin niya. Okay? So, ganun yung ginagawa ng atom natin, no? For example, uranium. Okay? For uranium-238, no? So, ang kanyang atomic number ay 92. Sorry, mali yung uranium ko dito. It should be 92, sorry. Hindi siya 82, 92.
Okay? Sorry for that. Okay. So, ayan. For example, uranium-238. Okay? So, uranium-238, 92 yung kanyang proton. So, ano sabi natin? Kapag greater than 83, alpha emission. So, yung gagawin niya, alpha emission. Okay? Then ito, this is some series of reaction lang, beta emission. Para so, mag-alpha emission siya, then babalik ulit siya sa uranium by beta emission. Then, mag-alpha emission ulit siya until it reaches proton number less than 83. Okay? So, ganun ginagawa niya. Alam ng nucleus gagawin niya. Okay? So, mag-alpha emission siya, babalik sa uranium, then mag-alpha emission until maging less than 83 siya. Then, magta-transform uli siya, then alpha emission, so on so forth. Okay? So, alam ng atom natin yung ginagawa niya sa sarili niya. Okay? So, dahil doon, nalalaman natin yung mga nalalaman natin yung mga byproducts ng isang nuclear reaction. Pwede mo ma-predict kasi. Okay? So, you can see din na in this process, nagbabago-bago yung elements, no? Okay, so for example, you have uranium, then magiging siya, polonium, radium, radon, bismuth, tellurium, lead, no? Okay. So, ganun. So, ang point lang dito is that, ang point dito is, yung element natin nagtatransform into more stable atom, no? So, alam ng atom yung gagawin niya. Kung siya ay mag-alpha emission, beta emission, positron emission, electron capture, o kaya gamma emission. Okay? So, ganun. Alam niya ang gagawin niya. Okay? So, yan. Okay? So, yan. Next one, we have nuclear bombardment reaction. So, ito naman yung ginagawa kapag you want to combine two nuclei to form new nuclei. Okay? So, for example, ito yung nangyayari sa star. No? So, sa star natin, for example, hydrogen, i-combine mo with hydrogen to produce helium. Okay? So, ito, na-discuss ko rin to dati sa physical science. No? Pakita ko yung star. No? Nuclear reaction star. Ito, yung stellar nucleosynthesis. Nakwento ko to dati sa aking mga bata. Okay, for example, ito yung mga nuclear bombardment reactions. I-combine mo yung dalawang nuclei to form other elements. Okay? For example, you have hydrogen, hydrogen. Pagsamahin mo yan, you will form helium. Okay? Then yung helium na yan, pagsamasamahin mo yan, later on, you will form lithium. Then later on, magiging magiging beryllium, boron, carbon, until iron. Okay? So yun yung nuclear reactions natin sa star. Okay? Or the stellar nucleosynthesis. So ganun yung idea dyan. Dalawang atoms na magkaiba, pagsasamahin mo to form bigger elements. And ito yung technique na ginagawa nila to develop elements na bago. No? For example, the organeson. So, ang organeson na form lang yan by combining certain elements. No? Okay? So, pinagbunggulang nila yung dalawang elements. So, yun, na-form yung organeson, the heaviest element known. Okay? So, ang tawag sa process na yon when you combine two elements to form new element, tawag doon is the transmutation. Okay? So parang ito yung hinahanap ng mga alchemists dati. Yung pagsasamahin mo yung dalawa to form gold. Okay? So ang sagot doon ay transmutation. Hindi siya alchemy talaga. Transmutation siya. Okay? So ito yung ginagawa to combine two nuclei to form bigger nuclei. Okay? For example, we have here nitrogen 14. If you combine it with helium, you will produce oxygen 17 and proton. Okay? So, ganun. So, itong nuclear bombardment reaction natin, this can be simplified, no? Paano? Yung mga elementary particles natin such as alpha, beta, gamma, mga positron, pati mga protons, no? Iko-condense mo siya. Okay? So, ang focus of interest mo dito ay yung element na changing. Pero yung fundamental particles, hindi. No? Yung elementary particles, hindi. For example, helium is an elementary particle. Alpha yung symbol niya. Hydrogen is an elementary particle. P yung symbol niya. So, pwede mo ito i-disregard na. Ang ipapakita mo lang yung conversion nito into this. No? So, yun yung gusto mo ipakita. So, yun. So, on the left, you will write it like that. On the right, you will like it at that. Then, yung elementary particles mo na alpha and proton, susulat mo within the parentheses. No? So, the comma signifies the arrow. Okay? So, ang meaning lang nito is neutron plus alpha, comma, proton plus this element. Okay? So, this plus this, producing this plus this. Para siyang ano, para siyang, naalala nyo yung sa electrochem, yung cell notation. Parang ganun lang din dito. Parang left, anode, cathode, di ba? Parang ganun din dito. So, left, this one, right, ito. Okay. So, ito yung reactant, ito yung product. Then, yung elementary particles, yun yung i-condense mo. Instead of writing this, you write it as alpha or letter P. Then, lagyan mo lang ng comma to indicate na may arrow pointing to the right. Para siyang cell notation lang. Okay? Turuan ko kayo how to abbreviate these elements, abbreviate these symbols into our notation. Okay? The transmutation notation. For example, we have this one. We have 9 for beryllium, helium for 2, 12 6 carbon, 1 0 neutron. Okay. Ano yung mga elementary particles mo dyan? Yung helium, alpha yan. Yung neutron, letter N lang yan. So, ibig sabihin, you can rewrite this as 9,4 beryllium, parenthesis, alpha, comma, neutron, close parenthesis, 12,6 carbon. Okay? Paano ko nagawa yun? Sabi ko sa inyo, yung mga elementary particles, i-shortcut mo siya. Ano yung elementary particles? Alpha, proton, neutron, beta, electron, positron. E plus yan kapag positron. Or beta plus. Okay? So, yan. So, ito yung mga elementary particles natin, include gamma. Okay? So, ito yung mga elementary particles na i-shortcut mo. Yung hindi mo i-shortcut, yun yung ibang elements, no? Such as beryllium, carbon. Sila yung nasa labas ng parenthesis. Okay? Yung nasa left side ng parenthesis, yun yung nasa reactant, which is the alpha. Yung nasa right side ng parenthesis, yun yung nasa product, which is the neutron. Yung arrow, indicate mo yan with a comma. Okay? Ito, sasagutan ko to lahat, don't worry. Kunwari, ito. Aluminum 27 for to helium, 30 phosphorus, 1 neutron. Paano ko isusulat yan? O yung alpha, shortcut mo yan. No, neutron, shortcut mo yan. Okay? On the left side, you have 27, 13 aluminum. Open parenthesis, ano yung nasa left na elementary particle? Alpha. Comma, meaning nun may arrow. And then on the right side, ang elementary particle mo ay neutron. Close parenthesis, followed by your element. 3015 phosphorus. Okay, so ganun. Okay, so ayan. How about this one, number 3? 4020 calcium, 21 hydrogen, 4120 calcium, 11 hydrogen. Paano kaya ito? Okay, so may introduce ako na ang 21H, pangalan yan ay deuterium. Di ba tatlo yung isotopes ng hydrogen? We have the protium, deuterium, and the tritium. Protium, deuterium, and tritium. Okay. So if you see one of them, you can abbreviate them as well, okay? Okay, so pwede mo siya kapag protium or hydrogen lang, letter P lang yan. Kaya nga letter P yung symbol niya doon. Pag deuterium, pwede mo siya i-abbreviate as D. Okay? Pag may nakita kayong D, deuterium yan. 2-1H yan. Kapag tritium, letter T. Okay? So, yan yung kanilang mga symbols. No? Okay? So, ibig sabihin, itong hydrogen 2, you can abbreviate this as letter D. Okay? Letter D, meaning deuterium. Okay? So, this one can be abbreviated as letter D, deuterium, 2-1H yan eh. And this is protium pa rin, or letter P. So, you can rewrite this as 40-20 calcium, D, comma, P, then 41-20 calcium. Okay? So, again, yung mga nasa left side, yun yung nasa reactant. Yung nasa right side ng comma, yun yung nasa product side. Yung nasa loob ng parenthesis, yung elementary particles mo, such as alpha, proton, neutron, electron, beta minus or E minus, positron, E minus or beta plus, gamma, which is letter Y, and then you can also write deuterium and tritium as letter D and T. Okay? For example, another one, you have this one, 2713 aluminum, proton, deuterium, 2313 aluminum. Okay, so anong gagawin mo dito? Just follow kung ano yung ginawa natin dito, but in reverse. Okay, so anything on the left side is the reactant, anything on the right side is the product. So 2713 aluminum plus the proton. On the right side, you have the D, which is deuterium, plus aluminum. Okay, so ganun lang. Balance na yan. Again, emphasize ko lang, anything on the left side of the comma is the reactant, anything on the right side of the comma is the product. Ang abbreviated sa loob ng parenthesis ay yung mga elementary particles, such as this and this. Balance yan. Kung mapapansin mo, 27 plus 1, 28. 26 plus 2, 28. 13 plus 1, 14. 1 plus 13, 14. So, balance to. Last one. Sinagutan ko na lahat, no? Kasi medyo confusing to sa iba. Even sa mga klase ko dati, medyo confused sila. Kaya, sinagutan ko lahat. Okay. So, ito. Let's have number 5, 12-6C, D, P, 13-6C. Okay. So, ano meaning yan? Sa ng comma, deuterium pati carbon 12. So, sulat mo dyan, carbon 12, deuterium to 1H yung symbol nun. Yung nasa right side ng comma is P and 13 carbon. Okay? Sulat mo yan as 11H, 13-6 carbon. Okay? So, yan. Di naman natin to kailangan masyado, no? Kaya ako yung nagsagot ng lahat. Pero you will encounter this in the future maybe, no? Kapag may mag-pursue sa inyo ng higher degrees, no? Nag-aral kayo ng nuclear science in the future, mas makikita nyo to madalas, no? Naka-shortcut siya. Okay, so hindi natin to masyado kailangan for our semester, pero at least may idea kayo how to read this, no? May alam kayo ano meaning ng P, meaning ng protium. Ito symbol nun. Ano meaning ng D? Deuterium yun. Ito symbol nun. Alpha, alam nyo na meaning yan. 42He lang yan. Neutron, 10N. Okay? So that's how you read the abbreviated notation. Okay? So, ganun lang. Hindi to kailangan for the semester, pero sinama ko na. Para aware kayo. Okay? Kasi pag nag-google kayo, makakakita kayo ng ganito talaga. Okay? So, yan. Okay, so hanggang doon lang yung ating lesson muna. Okay, medyo marami na tayo na kwentuhan kahit papano. Ang dami nangyayari. Pero ganoon, basic lang naman yung nuclear reactions, no? So, again, just to summarize everything. Okay, yun, so nuclear reactions are different with chemical reactions. However, they still follow the law of conservation of mass, no? Still follow the law of conservation of mass. Okay? So, yan. Yan yung difference natin. Mas energetic ang nuclear kaysa sa chemical. That's why ito yung ginagamit ng mga stars natin, no? And also, nuclear reactions doesn't run out of fuel, no? Kaya ang tataka kayo yung star natin, patuloy yan na nagre-react for billions of years already kasi it doesn't need any other reactants, no? Kaya na niya mag-isa mag-react sa sarili niya. Okay? So yun something different with uh, nuclear reactions, no? Hindi niya kailangan ng ibang chemicals. It will just start immediately. Okay? So alam kasi ng atom kung ano gagawin niya eh. Kung siya ba ay mag-alpha emission, beta emission, siya ba ay magpo-positron emission, electron capture, no? So alam niya kung ano gagawin niya. Okay? Kaya ayun. Since alam niya kung ano gagawin niya, kaya na niya mag-continue on its own. Okay? So yun yung difference niya with chemical reaction. Stuff, no? To kick the reaction. Nuclear, it will just happen. Okay? So yun, na-discover yung nuclear, yung ating nuclear science, yung radioactivity. It was discovered by Becquerel, okay? Sa kanyang uranium metal na pinatong sa photographic plate, no? So napansin niya nagganyan yung picture. So ibig sabihin there is something there. No, may rays coming out from the metal. Hindi niya alam kaya tinawag niyang X-ray, okay? At yun yung ginagamit natin sa ating mga X-ray pictures, no? Okay. So later on, na-discover nila that yung ating particles, mga radiation, maraming uri pala yun, no? May mga alpha, beta, gamma. May positively charged, may negatively charged, and mayroong walang charge, no? Okay, so nuclear equation, ayun, naka-nuclear symbol siya. So when you say nuclear symbol, ganito yon. You have the element, the mass number, the proton number, and the charge. So yan yung nuclear symbol. Nakaganon lahat ng ating chemicals dito. Okay, so yan, nakaganyan sila lahat. And then in order to balance them, sabi ko sa inyo, yung mass ay balance dapat, pati yung proton number ay balance, no? Or in other terms, yung mass, yung proton pati neutrons dapat balance, okay? You just balance the numbers on the top number and yung bottom numbers, no? Okay? So kunwari, 238 dito, kailangan 238 doon. 92 dito, kailangan 92 din doon. Okay? Kapag hindi yan balance, then you have to do something else, no? Okay? So ito yung mga pwede mo pa idagdag: proton, neutron, electron, positron, alpha particle, no? And yun nga, nakwento ko pa kanina, we have gamma particles. That's gamma. Sorry, double M. That is a gamma particle. Gamma. This one is deuterium. And this one is tritium. Okay, so ang symbol niyan ay letter D. Ito ay letter T. Ito ay gamma. Symbol na to P. Symbol na to N. Symbol na to E or beta. Symbol na to ay E positive or beta positive. Symbol na to ay alpha. Okay? So yun yung mga dinadagdag natin dun sa nuclear symbols natin kanina. Okay? So yan, balance lang. Kailangan number sa taas at number sa baba ay equal. Left, right. Kailangan equal yan. So yan, bakit nga ba nagiging stable yung atom? It is because of the strong force, no? Ito yung rubber band sa papel. However, sabi nga natin, hindi lahat ng rubber band matibay. Okay? Ibig sabihin nun, kapag masyadong maraming protons, radioactive na yung atom. Hindi na kaya ng rubber band. No? So, it just spews out any other particles. No? So, nag-undergo na siya ng radioactive decay. Okay? So, yan. Paano mo malalaman kung stable yan? Well, we have the magic numbers. No? If your proton or neutron has those numbers, ibig sabihin stable yan. We have the even proton neutron numbers. Kapag even yan, so ibig sabihin most likely stable sila. Okay? And then if your atomic number is greater than 83, unstable na yan. Okay? Ang exception would be technetium and promethium. Okay? So yan. Okay. So if you graph your nuclear stability, if you graph your isotopes rather, you will form this line called the band of stability. Mapansin mo, 1-to-1 ratio yan at first, but starting at calcium, it will start to deviate from the 1-to-1 ratio. Bakit? Kasi masyado na maraming protons. So, kailangan maraming neutrons din. Okay? Kaya doon siya nag-start mag-deviate. Okay? And so, yun. Compare lang kayo ng proton, neutron, and so on. Ito, types of radioactive decay. Paano mo malalaman kung anong radioactive decay gagawin niya? Pag alpha emission, greater than 83 yung atomic number. And then, yung beta emission, positron emission, electron capture, it has something to do with the neutron to proton ratio. Okay? Ko-compare mo siya with the stable one. Gamma emission, rearrangement lang yan. Kumbaga, nag-shake lang yung atom. Kapag nag-shake siya, lumalabas yung gamma rays. Okay? Spontaneous fission, meaning naman nito, yung isang element, no, marami siyang nilalabas na other elements, no, more than one. Okay? So, ito yung summary ng ginawa natin kanina. Okay? Radioactive decay series, ito, pinakita ko dito that yung atom natin, alam niya kung ano gagawin niya. No? For example, uranium, greater than 83 siya. So, mag-alpha decay talaga siya. Then, once na pasok na siya sa 83, doon na siya pwede mag-other forms of decay. No? Such as beta, pwede rin siya electron capture, positron emission. No? So, yun yung mga other na pwede niya gawin. Okay, so nuclear bombardment reaction, ito lang pinakita natin that we can combine two elements to form newer elements, no? And they can be abbreviated in this manner, wherein yung ating elementary particles can be written as alpha, beta, gamma, letter D, letter P, letter T, so on and so forth. Okay, so yan. Okay, so next meeting we will continue with radiation and matter. So sa Sabado to, discuss natin how do we detect nuclear radiations. Okay, discuss natin yon. Paano na-detect yung radiation, ano yung effect niya sa body, paano mo malalaman kung gaano katagal mawawala yung radioactivity sa isang area, how to do carbon dating. Okay, so calculation tayo dito sa part na to, and saan siya ina-apply. Then siguro next week Wednesday discuss natin yung energetics. No? Madali lang yan. Okay. So that will be all for our session today. Yan. So thank you. No, medyo matagal yung session natin. No? Sinagad ko na para mahabol natin yung lessons. Kasi again, yung ating calendar ay adjusted. Okay, adjusted siya. Sa mga bagong dating, akala ko kasi itong week na to yung finals. Yung pala, ito yung finals until 21 July. So mag-a-adjust tayo ng lessons. Okay. Kaya hinabol ko yung lessons. Okay. So anyway, you can rewatch the video naman, no, if in case na nabilisan kayo. Okay. So that will be all for our session today. Thank you and I'll see you again this Saturday. If may question, wag kayong mahiya magtanong. Message lang kayo sa akin sa FB. Okay. Okay. So thank you and bye-bye. Ingat always.